Thank you, everyone, and very nice to be here again. I realized that I actually come here every year. Sometimes it's twice a year, which is really nice to get to see colleagues and people to discuss, all the subject that we work together. And I would like to spend these 10-15 minutes to to discuss and share my thought about something that have been kind of bothering me for some time. And I think this will be a good opportunity to discuss with people in this room. So I will start my talk with these simple but important questions. What is epidemiological unit in aquaculture? Yes. And as an epidemiologist working in this field, I get asked this question very often. And I could simply point to WUA definition, which is state that epidemiological unit is a group of animals that share approximately the same risk of exposure to a pathogenic agent with a defined location. And I know that definition alone probably raise even more questions in your mind, because how we determine the same risk exposure, and how do we decide it on the defined locations. All these questions, I promise you that I would not have a solution for you today, but I would like to ask even more questions and then encourage the thinking around this definition. Because epidemiological unit define a proper epidemiological unit in aquatic environment is nothing but simple, but it's very important. The units form a foundation of how we define a population of aquaculture system. And it is the unit is a cornerstone of how we establish the effective surveillance, biosecurity, and disease management strategy. The aquaculture farm establishment is highly diverse, and this comes in many forms. And each of them is very very diverse and depending on the environmental interaction, the control over animal entry and exit, and so on. And they have a different level of biosecurity. So WUA aquatic code and manuals have provided international standard or guidelines aimed at improve aquatic animal health and ensure safe trade of aquatic animal and their products. And in the aquatic code, aquaculture farm or establishment can be categorized in four different categories of production system, which are closed system, semi-closed system, semi-open system, and open system. And this system is vary. The category of this system depend on the capacity of the establishment in control or treatment of water entering and exit, and control over animal coming in and going out. So basically have to do a lot with the water. So now back to another question, how we define epidemiological unit in these four different production systems. Let's take a look at this closed system. This is a closed system broodstock facility. It's very highly biosecure and have multiple preventive measures in place. The seawaters were pumped from at least 30-meter depth and recirculated and treated with UV ozone biofiltrations and to eliminate pathogens. They have a separate department between freshwater and seawaters, have very strict disinfection, control, movement of, there's one way of animal movement, And there are continuously check for water and have a robust monitoring and surveillance checking for the pathogens. So the question also now, can we consider this facility, the entire facility, as a single unit? Or can it be multiple units? What do you think? We'll come back to that. Yeah. And this is an example of semi-closed polyculture system where they cultured tilapia, catfish, and koi carp in the same location and in the different ponds. And they have a hatchery which is located next to the earthen pond. So can we consider different ponds as the different units if there is no direct water contact between them? Or can we consider hatchery as a separate unit from the earthen pond? Yeah. And another example, the next one is semi-closed production system of sea cage that farming salmon. Each cage can hold up to 500,000 fish. And the minimum, the distance between one cage to another cage from the same farms, typically ranging between 20 to 50 meters, depending on the farm layout and environmental conditions. And the minimum distance from one farm to another farm is between, the minimum is between 2 to 5 kilometers, depend on the regulations. So what do you think? For this system, do we consider a unit as a cage or a farm? Or can be a multiple cage within a farms? Or it should be a multiple farms within a production cluster of this system? Yeah. So I'm thinking about this, and then I believe that the epidemiological unit must encompass these three key dimensions: the physical, biological, and temporal dimensions. Yeah. So the physical dimensions, this is involved based on the physical barrier, boundaries, and this could be depending on the water share system, depending on also the size of the productions. And for biological dimensions, we need to think thoroughly about about the pathogen and host species. Thinking thoroughly to have a thorough understanding about the host susceptibility, think about the host species susceptibility, host and pathogen interaction, and so also environmental influence the pathogen survival, as well as the temporal dimensions. This is very important, how the risk exposure change over time, because monitoring the change of the risks over time is very key, important of how we define the change of the risk of the population over time. So not taking into consideration of the temporal dimensions or mismatch. For example, the disease, the health status, it could actually causing the consequence on the defined risks to define the epidemiological unit. Anyway, well, another question that I would like to raise is that have we think thorough enough? Can we think enough? Do we actually take into consideration of these three dimensions when we define our epidemiological unit? Yeah. And so I want to mention about how GIS actually can be we know that GIS is instrumental and very useful for defining surveillance. And in this example, I'm showing that when there is an outbreak of important disease happen, The first thing what we do is we have to set up the zone. And in the red area is the infection zone, which is including the location of the outbreak, where the control measure, a very strict control measure is implemented to prevent the spread outside this zone. And then surrounding this infected zone, we have a protection zone, which is we have enhanced screening and protective measure in order to protect unaffected population from the disease. And another zone that I would like to introduce, and maybe you have been used it already, I would call it like a coordinate biosecurity zone that we should establish it in advance, like proactively, where the zone were based on the water system connections and the activity with the farmer activity that are connected in order to encourage the farmer that to prevent to coordinate the activity among the farmer together. And we have heard of a very advanced technology and tool this morning, which is very impressive. And I really happy that I'll be here and then listening and see that how the work has been done, because all this advanced technology should be used and applying in our field. And this is one of the work that has been done by our institute. And just one of this example that we have integrate the advanced technology with GIS tools to predict the spread of the disease. And what you see is the result of the map that we call is a risk map that identify the area of higher risk. So basically, for this study, they use risk-based spread model to simulate the spread of pancreas disease in Atlantic salmon farm in Norway. And this risk-based is based on the movement of whale-boat compared to seaway distance. So in order to get the information about boat movement, of course, we require knowing the location, GIS, and things that included in the analysis. And another example that I want to mention here is the another GIS-driven management by the Norwegian government that initiated to regulate the growth of salmon farming. So instead of let them expand it unchecked, they control and regulate it by using environmental indicator and knowledge on the spread models. For this one, they're using this is spread model of sea lice dispersions and combined with the environment indicator. So the government has the area divided into 13 different management area. And then they're producing the through the veterinary institute, we have the map to identify the area with the high risk. And also this coming up after this study, there are also a regulation how we control spread of the sea lice. Yes, so yeah, back to the question again. Have we really think thorough enough when we define epidemiological unit, and have we actually apply the definition into practice to maximize the impact of the knowledge of epidemiological unit to minimize the spread of the disease. So this is another thing that I want to emphasize today. And before this is the almost the last slide, which I think is as important as the properly defined epidemiological unit is to have well communication with all stakeholders, regulator, farmer, scientists, or even among scientists ourselves, to have a well communication and share a common understanding about how we define from the very beginning how we define, how we monitor, and how we manage the unit. And this could be done in multiple ways. As an example that Ana Maria mentioned, that we have a collaborative workshop. Martha discussed about, and also we have to have a shared data platform that everyone can have access to the informations, and also to encourage the transparency of the result of the work that we have done as well. And also have visual tools that the importance of thing is to have data that continuously and provides more real time for to be able to manage the disease in the way that more proactive instead of reactive response. Um, yes, so I will leave you with these key messages, 4 key messages. One is the defining epidemiological unit with precision is a key, is important, because now with all the advanced technology and tool, we could do better. We can define better, and integrating all the advanced technology and tool that we have, we can become more, we can understand the disease dynamic in the more full pictures and become more um, proactive and also in real time. In collaboration is a key for any control, disease control. Real time monitoring for proactive management, as I mentioned earlier. Yes. So I think this is how I would like to leave you with these key messages. Thank you. Yeah. Yeah. No more questions. Yeah.
Nicola is complaining because you haven't given us any answers.
That's it. That's what I said earlier that I would, yeah, actually, I would like you to take this back and then think about how we, because it's there are way there are, because it's not like we don't have a solution, we have, but we, how we going to implement it and how we going to improve it with the existing tools that we have. I actually, this morning section, I heard the question from Manuela about how we can implement all this work and how we can get the message down to those who actually use it. And I think this is go right to the point, and it's a key, and it's very important things that we need to think about it. I remember when we working in Africa, um, we create a webinar amongst all stakeholders. We discuss about the work that we have done and everything. We have governmental official, we have scientists, and then at the end in the question answer session, a farmer was raised his hand and he said that I have a question. And he said, if I have an outbreak in my farm, who can I tell? Who can I talk to? And we realized that no, we haven't done the very important things. He doesn't even know, this is kind of a message that we get. And I think something